Hello. I'm going to begin talking about arithmetic during this video. Arithmetic is the branch of mathematics that deals with numbers. No variables, geometric shapes, or graphs, just numbers. It is the foundation of mathematics and is basically what you learned during your elementary school days. The interesting thing is that most problems that people have in advanced mathematics have a root cause in things they didn't completely understand in arithmetic. So these arithmetic topics are important. Mathematics is like a building. If you have problems with your foundation, then the building is going to be unstable. If you have trouble with certain areas of arithmetic, it is going to affect other areas of math. So I'm not going to talk about everything in arithmetic, but I'm going to concentrate on areas that people often find difficult. Take my word for it, the time you spend in brushing up on your arithmetic skills is going to pay off in the long run. In my experience, the areas of arithmetic that people struggle with are working with negative numbers, working with fractions and decimals, working with exponents and roots, and working with irrational numbers. In addition, there are some arithmetic laws, properties, and definitions that are important to know, which are probably a little bit rusty right now in your mind. This is a lot of area to cover, so I'll be breaking this up into a series of videos. I'll also have some practice videos where you can test your understanding of these topics. So let's get started working with negative numbers. Are you ready? I said, are you ready? Much better. First, let's lay out the integers along a line. Not surprisingly, this is called a number line. A number line really just helps us understand the relationship of numbers to each other. If you're unfamiliar with the term integers, then take a look at the earlier video on types of numbers. We can think of any number as having a magnitude and direction. The magnitude of the number is the distance the number is from zero, and the direction is which way the number is from zero. That is, the positive or negative direction. By convention, we say that numbers to the right of zero are positive integers, and that is the positive direction, and numbers to the left of zero are negative integers, and that is the negative direction. Negative integers have a minus sign in front of them. Positive integers don't have any sign in front of them. So the number 5, for instance, has a magnitude or distance of 5 units in the positive direction from 0. The number -4 has a magnitude or distance of 4 units in the negative direction from 0. I use the term units because we can use this concept in many different ways, so I want this to be universal. When we work on problems in the real world, we may use units of feet, miles, dollars, any unit which makes sense to what we're trying to solve. Let's look at a simple arithmetic problem. Let's figure out what 5 plus 2 equals. I can solve this problem by starting from 0 and moving in the magnitude and direction of the first number, that is 5, and then moving in the magnitude and direction of the second number, 2. I get a value of 7, which probably doesn't surprise a lot of you. Now let's do a little subtraction. First, if I wanted to solve the arithmetic problem, what does 5 minus 2 equal? I would start from 0 and move in the magnitude and direction of the first number. Since subtraction is the opposing operation to addition, I would change the direction of the second number and move along the number line a distance equal to the magnitude of that number. So 5 minus 2 equals 3. Let me summarize that again. For addition, we simply take each number and move along the number line corresponding to the magnitude and direction of each number. For subtraction, we reverse the direction of the second number and move along the number line corresponding to the magnitude and new direction of each number. For positive numbers, this all makes a great deal of sense to us. If you have 5 marbles and I give you 2 marbles, then you are gaining marbles. That is, you are moving away from having 0 marbles. The total number of marbles you have is positive and gaining magnitude. You are getting more. If instead of giving you 2 marbles, I take away 2 marbles, then you would be moving closer to having 0 marbles. The total number of marbles you have is positive, but it is losing magnitude. You have fewer marbles. We don't do anything differently when we deal with negative numbers or a mix of positive and negative numbers. Working with negative numbers is often difficult for people because negative numbers don't have many applications in the physical world. After all, if you only have 2 marbles, I can't take 4 marbles away from you. We don't go out and jog -3 miles. Recall, though, that negative numbers came about historically when we start to borrow and lend money. Say that you and I went out to lunch, but when we got there, the meal that you want costs $7 and you only have $5 in your pocket. I agree to lend you the additional $2 that you need. When you walk out of the restaurant, you have a full belly, but how much money do you have? You can look in your pocket and notice that it is now empty and think that you have $0, but you don't. You have -$2 because that is how much you owe me. If you're a good friend, then the first $2 that come your way are going to go towards repaying me for the loan. Before we go further, let's talk for a moment about a math convention that sometimes confuses people. In this sense of the word, a convention is simply a way in which something is usually done. Recall that math is, among other things, a language, and a language has conventions which are particular to that language. If I tell you, I saw a man saw a tree, we rely on our understanding of the English language conventions to know that I'm using 2 entirely different meanings for saw in that sentence. The math convention I want to discuss is the minus symbol. The minus symbol represents 2 different things in math, and sometimes we get confused as to the meaning. As I mentioned before, when I write a number like -3, I use the minus sign to denote that number is a negative integer. When I write 5 minus 2, then I'm using the same minus sign, but it now denotes that I am performing a mathematical operation on the 5 and 2. Specifically, I am subtracting the second number from the first. The concepts are similar, but not the same, and sometimes we use them interchangeably and get confused. When I want to make sure there is no confusion, I put parentheses around the negative number. I might write an expression like 5 plus -2 in this way. If we stick to the concept of integers being represented by magnitude and direction, and we use the rules we have already laid out for addition and subtraction, we don't have any problems with negative numbers. This may be easier said than done, but let's try it. Let's do addition first. Let's try -4 plus -3. Move along the number line in the magnitude and direction of the first number, and then move in the magnitude and direction of the second number. We find that -4 plus -3 equals -7. Let's try a couple of more additional problems. How about 5 plus -4? Let's try -4 plus 6. Now let's try some subtraction. Recall that we do the same thing as in addition, but we change the direction of the second integer. Let's try 3 minus 6. Now let's try -3 minus 2. Now let's try -4 minus -3. It always works. The concept of a number line is good for laying out an understanding of addition and subtraction using negative numbers, but it is often difficult to put into practice. If I have a problem like solving the expression negative 104 plus 63, then taking the time and space to draw out a number line is not practical. So we can come up with general rules for addition and subtraction of integers. Here are the rules for the addition. The first rule: if the numbers have the same direction, that is, both positive or both negative, then add the magnitudes of the numbers and take that common direction. So 15 plus 43 equals 58, and negative 15 plus negative 43 equals negative 58. More simply put, adding two positive numbers together always gives you a positive number, and adding two negative numbers together always gives you a negative number. The second rule: if the numbers have different directions, then subtract the smaller magnitude from the larger one and take the direction of the larger magnitude number. So, negative 15 plus 43 equals 28, and 15 plus negative 43 equals negative 28. Now let's talk about subtraction. You may have noticed a couple of things. 4 minus 3 gives us the same result as 4 plus negative 3. That is, subtracting a positive number is the same as adding a negative number of the same magnitude. Similarly, you may notice that 5 minus negative 2 is the same as 5 plus 2. That is, subtracting a negative number is the same as adding a positive number of the same magnitude. That's good, because now all you have to do is convert the subtraction problem into an equivalent addition problem and then use the rules for addition. So, rules for converting a subtraction problem into an addition problem. The first rule: if you're subtracting a positive number, then change it to the equivalent form of adding a negative number of the same magnitude. Second rule: if you're subtracting a negative number, then change it to the equivalent form of adding a positive number of the same magnitude. Let's try a few problems. Let's take 57 minus 93. This is subtracting a positive number, so first we write it as 57 plus negative 93. Now, since the numbers have different directions, one positive and one negative, we subtract the magnitudes, small from large. 93 minus 57 is 38. That gives us the magnitude of the answer. The direction of the answer is negative, since the larger magnitude number is negative. The final answer is negative 38. Let's take 57 minus negative 93. Since we are subtracting a negative number, it is the same as adding a positive number. We change the problem to 57 plus 93. Since both numbers are now positive, we simply add the magnitudes and get 150. During this whole time, I have been working with integers, but all of this discussion applies to any real numbers. Integers simply make it easier to envision the rules, but the rules don't change even as we start to get into messier, rational, and irrational numbers. Remember that dealing with negative numbers is one of the major problems that people run into learning math, so it's likely going to take some practice and maybe reviewing this video a couple of times before the lights turn on and you are bathed in the golden glow of understanding. But if you put in the effort, it will happen. and you will have made an important accomplishment in regards to shoring up your math foundation. There is a practice video that you can access to test your understanding of this topic. Thank you, and have a wonderful day.
We hope to see you at Veterans Upward Bound very soon, and recommend a friend.